Modal analysis computes the structure's natural periods, mode shapes, and modal participation, its dynamic properties, independent of any applied load. These results feed directly into other tools in the application. The fundamental period, T1, is used by pushover's code-based load pattern and by the spectral shape factor calculation in collapse risk assessment under FEMA P695. The mode shapes themselves are used by modal pushover analysis and adaptive pushover. This isn't a standalone result. It's an input other analyses in this series depend on. Modal analysis solves an eigenvalue problem that depends on both mass and stiffness. Without mass assigned, no meaningful period or mode shape can be extracted. If mass isn't already assigned in the main TCL file through mass commands, it's entered here instead. Set NDF to match the model's degrees of freedom per node, then enter one node value pair per line. Insert mass block into model adds the corresponding mass commands directly into the code editor. Number of modes sets how many modes are extracted, 3 by default. Damping ratio is used for the Rayleigh damping calculation, 2% by default. Rayleigh damping needs 2 anchor modes, by default, modes 1 and 3, so the specified damping ratio is matched exactly at those 2 modes' frequencies. Damping at every other mode follows from that anchoring, not from a separate input. Attempt participation factors is ticked by default. It has the analysis try to compute modal participation factors and effective modal mass using OpenC's modal properties command. This is explicitly best effort. That command isn't available in every OpenC's build. If it's missing, the analysis still completes and reports periods and mode shapes normally. The results panel shows that participation factors are unavailable rather than failing outright. Generate refresh TCL builds the modal analysis code from these parameters into the preview. Insert TCL into model adds it to the code editor at the cursor position. Run modal analysis executes it. You can run it from the model analysis window or main window once inserted to the code editor. Results populate 2 tables. The first lists mode period t in seconds, frequency in hertz, and angular frequency in radians per second for each extracted mode. The second, effective mass participation ratios, shows what percentage of the structure's total mass each mode captures when participation factors were successfully computed. This is the check for whether enough modes were extracted. A common target is 90% or more of the total mass in the direction of interest. If that threshold isn't met, more modes need to be extracted, not just more confidence in the ones already computed. Mode shapes are extracted alongside the periods, the eigenvectors describing how the structure deforms at each mode. These aren't just diagnostic, they're the actual input modal pushover analysis uses to build its multi-mode load patterns, and what adaptive pushover references as the structure's stiffness changes during a run. Print report generates a document covering the extracted periods, mode shapes, and participation results where available. Working order in summary. Open the window, assign nodal mass if it isn't already in the model, set the parameters, generate and insert the TCL, run the analysis, then print the report.